Hi everybody, this is going to be our 6.2 notes video, and we're talking about rational exponents today. So exponents that look like fractions, but I want to talk about a couple just key vocabulary words here, things that you need to be aware of. When we're working with radicals, okay, a lot of times this symbol here that I'm outlining in blue, you think of as just being the square root symbol, but really there are other types of roots that we can have. So in general, that's really just called a radical symbol. And what determines the root that we're taking is this little number in here that we call the index. Now, if there's no number written there, then that means the number is really a 2, it's just hidden, and then it would be a square root. So we have a square root if our index is 2, but if it's an index of 3, it would be a cube root. If the index is 4, it would be a fourth root, and so on. And then the word for the thing that goes underneath the radical, what's actually inside, is what we call the radicand. So just some key vocabulary. This is going to be helpful for some of those words that you see throughout these notes. So sometimes we have rational exponents, and like I said, that just means that we have things that are raised to powers that look like fractions. Those are what we call rational exponents. So whenever we have exponents that look like this, we want to convert the expression, and what that really means is that we want to rewrite these into radical form. So the first thing we want to do is we want to see if we can actually simplify these expressions using our calculator, like see if we can actually calculate this base raised to this power. So the way that you would type this into your calculator would be 125, and then you're going to use that caret key, and then you're going to do parentheses, and then you're just going to do 1 divided by 3. So if you do that calculation, you're going to see that really this just gives us the number 5. Or when we do 64 to the 1/6 power, so again, you would use that caret key. Okay, 64 to the 1/6 power is just going to give us 2. 25 to the 1/2 power is just 5. So this whole expression becomes 7. But we can't always do that. And when we can't, we're going to have to convert. And this thing in the box that you see here is telling us how we convert. So if we're going from a rational exponent to radical form, notice that the numbers that make up my rational exponent are going to be moved to 2 different places. Since we're converting to radical form, we're going to definitely have this radical symbol in here. And the important thing that you need to know is that the exponent that has that a value and the b value, okay, the a value is going to stay underneath the radical symbol with your base. So we have x to the a power underneath the radical, and then that denominator of the rational exponent, the b value, is going to move outside, and it's going to become the index. Okay, so for example A here, I need to convert y to the 5/7 power into radical form. So I'm going to start off by just drawing my radical symbol. Now remember, the numerator of this exponent is going to stay underneath the radical symbol with your base. So we're going to have y to the 5th power underneath, and then that denominator of 7 is going to move down, and it's going to become the index. And this would be the radical form that we get when we do that conversion, okay, when we're going from rational exponent to radical form. So same thing for example B. I'm going to start by drawing my radical symbol, okay. We're going to have m to the 1st power underneath, and then that 3 that's in the denominator of that fraction is going to become our index. Now, let's say we start with something in radical form and we want to try to simplify that. Well, remember that the index is really the number that was originally on the bottom of the fraction for your exponents, for those rational exponents. The exponents that you see inside were originally the numerators of those rational exponents. So we just need to put it back into fraction form, essentially. So what we're really going to be doing is dividing each exponent underneath the radical symbol by the index. Okay, so this would become x to the 9th, but then we're dividing by that index of 3, and then y to the 3rd, but again, we're dividing by that index of 3. And then we can simplify. Okay, 9 divided by 3 is really just 3, so we have x cubed. And then y to the 3 over 3 power, well, 3 divided by 3 is just 1. So we have y to the 1st power, which is really just y. Now, at the very beginning of the video, I told you guys, what happens when we don't actually have a number written in that index position. If there's no number written, it's assumed that the index is 2. Okay, the square root is the one most commonly used, so mathematicians were just like, hey, you know what, instead of writing a 2 here every time, we're just going to say if you don't see a number written there, we're just going to assume that it's a 2. Okay, we have a square root if there is no number written in the index position. Okay, but we need to write it here because we know that we need to convert this back into rational exponent form. So we need to go back and divide our exponents inside by the index outside. So we get x to the 4 divided by 2 power, y to the 2 divided by 2 power, and again, we're just going to simplify those rational exponents by dividing. We really get x squared times y to the 1st, which again is just y. So that's it for this video. Let us know if you have any questions, and have a wonderful rest of your day.